Hello, hackers, and welcome. I'm Quinn. I'm a coach at Major League Hacking. I hope you're having a great time at Global Hack Week so far. I think this is day 5, and I think day 6 will be starting in maybe five hours or so. So yeah, I hope you're having a great time and that you've been building some really exciting projects. Welcome to another day, hackers. Very true, very true. I hope you're all doing well as well. And I'm glad you're happy to be here. This is super great. Welcome, welcome. All right, today we're going to be continuing with the second part of our series looking at open source LLM agents, in particular using LangChain. This is a super cool technology that allows us to build agents more easily. Yesterday we did a lot of the discussion around what an agent is and all of the concepts surrounding that. And we also started building an agent partly with LangChain, and we did some implementation from scratch. In particular, if you missed it, we built what's called the React loop, which is the reason act loop. And that is when we ask an LLM to think about what it wants to do, and then we allow it to act, i.e. call some tool or some function which we kind of define ourselves. We learned how to build a custom tool, and we learned how to incorporate that into the LangChain ecosystem. So I hope you're all kind of caught up. If you're not, don't worry, maybe we could do like a little speed through of our code. We didn't write a ton of code yesterday, we did a lot of concepts, so hopefully it won't take too long. If you want the link to the GitHub, I can pop that down in the chat as well. Yeah, actually I might do that now. In the meantime, while I find that link and pop it in the chat, please do check in. It's super great. If you check in, you get points. You can get some bonus stash for checking into 5 events. So it's very worth doing. The link is a little bit up in the chat, or I've just popped it on the screen now. And I'm going to grab the GitHub link. Let's see if we can find it. All right, here we go. There was some problem with the searching function last stream. I think it did work in the end. We did get it to work right at the end, but we did overrun slightly. So maybe you missed the last kind of 10 minutes or so, but it was working. But we'll do a little demo of it working again today. So I hope that's all good with all of you. Right, I'm gonna start out by sharing my screen. As always, I have a second screen up, which means that I can read the chat messages. So if I'm kind of looking away, I've got my laptop down here. This direction. I promise if I'm looking away, I'm not ignoring you. I'm gonna have to do some quick rejigging of all my screens now. Just bear with me for 1 second, hackers. It's nice to be here again. I'm glad to have you again. Welcome, welcome. But when I run it from my end, inputting the query, find recent Nobel Prize winners, it didn't give the proper result. Yeah, so it might be that because we're using DuckDuckGo and it's only fetching the top response and it's only fetching the abstract of the top response, it might just be that that just doesn't have the information that we're looking for, right? This is a very juvenile search tool. And later, maybe we'll use a more complicated one. So we can get to that. We've been working very much from scratch, building our own tools, building our own loops. But actually, we can do a lot of this with LangChain. I think it's helpful to have the intuition on how to build it yourself, but we'll replace this with LangChain maybe later if we have time. Okay, I'm just moving my screens around. Perfect. All right. Okay. All right. Hopefully you can see my screen. This is exactly where we left off yesterday. And let's do a quick speed run through of everything that we're doing. Actually, just very quickly, I'm going to put some tunes on. It's nice to have some background music, isn't it? Maybe not too loud, but cool. Okay, so we have all of our imports up here. In particular, we have LangChain and all of its associated bits and pieces. We've got Gradio as well, which is a UI front-end library. And we're loading in all our API keys. If you haven't done this already, you need Gemini API key. You could use a different model if you like. You'd have to import some slightly different bits and pieces here. We discussed this all yesterday. All right, I'm actually going to put on Pylance. I turned off Pylance yesterday. Pylance is like great, but sometimes it just doesn't recognize the stuff that you've installed. I'm just going to hope that disabling it and enabling it has fixed it. Previously, it didn't like, I think it was Sentence Transformer. It was just throwing a lot of red lines all over the screen, which was not my preference. I'm just going to reload my window. Okay. Whatever, this is fine. Okay, right. So, the first thing that we did was we discussed various bits and pieces about what an agent is, what a chain is, and how we're going to use them. And then we talked about this React loop, which is where the model reasons, it acts, it observes the output from the tool or whatever else it's using, and then we can repeat. You can see here that Pylance is really unhappy with me. Doesn't like this. Okay, I'm going to ignore most of these codes. What is this? I think this is probably an incompatibility between LangChain and Pylance. This seems not correct to me. We know our code works, so I'm going to ignore these. Right, okay, so let's talk it through it. We first built a client. Now, normally you'll just like load in a client from whatever library you're using, but in this case we're building a wrapper over the model provided by Gemini. And in particular, the reason we did this is so we could have a throttle, which meant that we couldn't just spam things faster than some minimum interval, because otherwise it could throw an error. And also, we invoked what's called an exponential backoff. And this is where we start off with a backoff. For example, 1 second, if we hit an error, let's say we try and call our model through the throttle, but then we get an error or some exception, we catch it, and then we say, okay, if we haven't done the maximum number of retries, I think by default is 5. Yeah, 5. We'll sleep for 1 second, and then we'll increase backoff up to 2 seconds. And we do that again, and then it's 4 seconds. We do that again, and then it's 8 seconds. We do that again, and it's 16. We do it again, it's 32. So overall, I think we could spend about a minute trying one query. This would be if we hit like all of our rate limits. It might make sense to make backoff slightly higher because most of our rate limits are defined in a minute interval. You can see, I think at the moment we're not having any issues with it, so this is fine. Okay, then we built what a minimal chain function might look like, and this is just passing in a system prompt, passing in a query, and then getting a response through our client and returning that. That was the whole. And then we thought, well, what if we wanted to use some tools? And so we built our own custom tool. We use this decorator, which is provided by LangChain. Through this decorator, we attach all sorts of information about this function and pass it into the model. And in particular, we used the DuckDuckGo API. This is super easy because we need an API key. It's free. It's great. But as someone pointed out earlier, we didn't get great results from this. Maybe we'll change to something different. We just pull out the first response basically, and we grab the abstract text. If we can't find that, we get related topics, which is like, again, this is like a pretty hacky kind of. This is not a very good tool that we've made here. It's like a fine tool. It works. But this is really kind of like a proof of concept, which is getting something that works. Okay? And then we built our agent. Okay, and this is that React loop that we spoke about. Okay, React style. Okay, and we initialized with our client, our tools, and then we bind the tools to our client. Okay, this is basically just saying, here we have a model, some LLM. let's give it access to all of our tools. All right, and then we set the maximum number of steps, which in this case was 10. So we can go through 10 different reasoning and action loops, and then that's initialized. We then also call this run function. Okay, we define this run function in our class, which we can call for our agent, and this produces the full loop. Okay, we define our system prompt again, and here we let it know that it has access to tools, and it should call the tool and give the appropriate output. Okay, then we loop through the maximum number of steps, and in this we allow our model to think, basically, and if it decides after its reasoning, this is this step here, which again, just as a reminder, LLM tools is created by binding tools to our client LLM, and this is defined up here. This is Chat Google Generative AI. Did I just say Googleative? That's not right. Chat Google Generative AI. There we go. And this is all imported. Okay. So LangChain is making things easy for us, and this is great. So we just invoke this, get a response, a message from our AI, and this might be a structured output saying call a tool, or it might be some other thought. Okay. And we're going to assume that it calls one tool at a time here, and then we're going to pull out the details of our tool, and we're going to check that we haven't seen it before. And now scene is just whether we create it. Yeah, here. Scene is a set, and we want to just make sure that we're not recalling the same thing over and over again. Sometimes agents can get stuck in a loop. This is very expensive because APIs typically cost money. And so this is a way that we can kind of check that we haven't done a repeated tool call. If we have, give that into the output. Okay. And then we basically grab the results from the tool. You can see that here, getting the observation out, and then we catch and handle the errors if needed, and then we add that into the message with the message history. Okay, this is a very juvenile way of handling message history, but it works. Okay, and then if we run out of time, i.e. we've done 10 steps and it hasn't given us an output where we would get output here, we say I couldn't complete the task within the allowed steps. Okay, and then we run the thing. So let's run this again. And maybe we'll put in a different question if anyone's got any suggestions. What would be different if we weren't using LangChain? So the biggest thing that we're using LangChain for at the moment, I mean, we're using it to create our client, right? But really, this is just like, we know, like we've done this before, if you've been to any of my streams, we can call up an LLM and get a response without LangChain. This is like nice and handy, but we don't need it. So this all here is kind of fine. This like invoke method comes from here. Again, like we could rewrite this fairly easily without using LangChain, but this is from LangChain and this is from LangChain. And then maybe the biggest thing is this. We would have to enforce the model's output when it's calling the tool ourselves. We'd have to handle it. Make sure that the model knows how to deal with this tool. At the moment, we don't tell the model, like, oh, this is a Python function, you should provide XYZ. We don't handle any of this, but we provide a doc string, and then this decorator jigs all of this and feeds it into our model in a way that the model can understand, and make sure that the model uses the tool correctly. Okay, and you'll notice that we get very few. We'll get very few of these errors generally, because the model is invoking the tool correctly. I don't think I've seen it not do this. And this is handled by LangChain. We could do this ourselves. It's not impossible. I've done this myself before without LangChain. It's not the end of the world, but LangChain makes this easier. And actually, this whole loop that we put up here, LangChain also provides for in a single line function. So we'll build that later. But I think it's helpful to see what we're doing. Okay, cool. So if anyone has a question, let me know. And also, if you have something you want me to ask, let me know. But maybe let's have a little think. Who was during? Tell me a fun fact about him. Okay, and let's not have that extra bit from there. Okay, now I'm in a terminal and I haven't activated my environment. Hopefully you are relatively kind of, maybe you've played the repo or you got it from yesterday if you're working along with me, but make sure you have a virtual environment with all of the things that you need in it. I didn't put requirements.txt in here, sorry, but let me know if you need the libraries required to install. Okay, perfect. All right. Yeah, all of this can be done not by default Python libraries, because obviously we need, like, you know, whatever we're using to handle like RLM. So this would, you know, maybe be Google Gen AI or whatever, right? There are various different options. OpenAI, perhaps. We would need like access to their APIs. But yeah, like all of, like, once you have an API, what an agent is basically just a for loop around the API. Okay, you have this for loop, and within this for loop, you say, okay, like, call some tools, do some thinking, like process the stuff. It's not like a radically complicated idea. Let me pull up some notes for anyone who's catching up. So this is maybe a helpful little image to have. We have our API, and then we put in our prompts, and it gives out some kind of like completion, some like, oh, this is what I want to do next, okay? And then we have some scaffolding, and we can build this by scratch, right? This is handled on our side. This is not handled in the LLM API, but we could do this with LangChain, right? This is what LangChain kind of does. LangChain is the infrastructure required to make scaffolding easier, but we could definitely code this all by scratch. It is absolutely doable. It's sometimes a little bit pain, but it's doable. Yes, for sure. So hopefully that makes sense. Oh, sorry, you want me to zoom in? This is better. With this. Yeah. Hopefully you can see it now. I'll leave this up for a second. Okay. Okay, right. I reckon we're kind of fairly happy now. Let's run the agent, and oh, we did put in a question. Let's see what happens. Okay, so when we're running this, we are putting in the minimal chain response. This doesn't have any access to any tooling. It doesn't have a loop. It can only just spit out what it thinks it knows. And then we also have the agent, and hopefully we'll see like some kind of difference here. It might not be like a brilliant difference, as I said. The tool that we're providing is not amazing, but it is an example of a functional tool. Okay, and we'll let this run. Perfect. Give it a minute. It's thinking. It's thinking for quite a long time, given it should send this print statement quite early. Okay. Right. Minimal chain response. Alan Turing, blah 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 blah. It's got some fun facts. Right, and we've got the message history output here. Okay. So the model has not succeeded in doing this. Let's have a little think about what this would be, and let's read the message history. So our model called search web function, and it queried who was Alan Turing. And the output was no relevant information found. This is a bit strange. We would expect to be able to find some information. Okay. Let's print the data here. There we go. So let's rerun this now, and we'll see what we get. Actually, I'm gonna just put in some like. Let's wrap that. Wait. Actually, we can put this up here. I'm just gonna put in some nice debugging print statements so that we can see where everything is. And where are we printing the message history? We should probably put like a this. Okay, right. Let's rerun it. And see what we get. We haven't changed any of the actual code apart from the fact that we're just printing some stuff. So let's do some debugging. We can see that it's calling the tool though correctly, right? The error is not with the model calling the tool. The error is with how our tool is working, and it's probably something to do with how we're dealing with data, because we're getting our summary as empty, which means that we're not finding any abstract text or related topics. So let's look at the structure of this data that's returned to us. Okay, so we're in the search here. Okay, interesting. So the search is just returning it. It's just got nothing in it, which is a little strange. We can go and look at the DuckDuckGo docs. This might be a good thing to do. I want to try like a different question and see if this is breaking across everything. So I feel like we did have this working today. What is the sure. Okay. Let's see what we get. Yeah, it could be a DuckDuckGo problem. Okay, let's see what we've got. So the minimal chain said, "Capital of France is Paris. I will now search the web for the latest news about Paris," but it can't. It doesn't have access to it all, so it just ends, which is fine. Okay, agent loop response. So we search it. Again, it seems empty. What do we search for? Latest news about Paris. This is extremely interesting. Yeah, so we definitely had this working yesterday. I'm a bit intrigued by this. Okay. Let's open the window and let's DuckDuckGo doc strings. Oh, this is handy. Okay, so this is an implementation of DuckDuckGo already in LangChain. I know that they did have some other search engine tools. Let's see, they've got quite a few actually. But I didn't realize they had one for DuckDuckGo search. Okay, we might just pivot using this because we've built our own tool now. Let's see if we can fix our function. That would be good. Why did I ask for doc strings? I didn't want that. API documentation. Did I type doc strings or did it also complete that? I feel like that was weird. Okay, this is categorically not what I want. Okay. This is cool. So we could change our function to allow the model to select the time period. And so if we asked for recent information, we could ask it to filter for the past months. This is useful for us to know. This is okay. This is not using DuckDuckGo's API. They're actually looking at this. I was like, oh, this is weirdly helpful, but it's not. Is this helpful? No. Let's just print what R is here. Yeah, and then run this again. Not very helpful so far. I think fundamentally, hopefully, we're happy with what we're doing though. And maybe we'll switch to using LangChain's search tool here. This might be a good thing to do actually, to show how you can use LangChain's tool, and then we can build another one of those. So, right, let's see what we got. Scrolling down. Okay, this doesn't work. This is fine. Comes of France, blah 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 blah. I am unable to browse the internet. There you go. Okay, agent loop response. Yeah. Hi, welcome. Okay, I think maybe this is weird. So that we're getting a 202, which is good. This is fine. You know what? Let's ask our friend Copilot. This is sometimes where Copilot can shine. Let's highlight the relevant part. If you don't have Copilot, I do recommend. What I'm going to do is grab the output as well. What is going on here actually? Why is this output sitting down? I assume this is just a bug. No, let's just grab it from the bug. Our custom search web tool using DuckDuckGo isn't returning any results. Help us identify why. And let's Let's use Claude. Why not? Let's give this a go. Okay, we can try some different parameters. It's worth a shot. I mean, this was working yesterday for anyone who was on the stream. Let's just try it. I mean, we are handling the errors. Okay, so basically, Claude just thinks that it's a rubbish API. You know what? I'm inclined to agree at this point because I can't find any documentation, and it's not doing what I want. But we'll give it a go. We just deleted the set of parameters and changed our the name of our what? So that does anything. Okay. This is fine and normal. It's getting like that. Okay, that's fine. We're getting just dummy responses from the API. I think the API is probably down. Production state offline. Yeah, I feel like the API is down. So this is super helpful for us, and I'm being fully sarcastic here in case that's not clear. What I'm going to do is we can just comment this out. This is a good example of how to structure a tool. Unfortunately, it doesn't work. This DuckDuckGo is rubbish at the moment. Let's see if we can do something a little bit better right now. So let me actually let's look at some documentation together. Okay, so let's say I don't think we want to use this. I don't think we want to use DuckDuckGo anymore. I like worried this is going to break in LangChain. But let's use a different tool. Let's use a different search tool. I think we should use Tavily. I feel like I've heard good things about Tavily. And we get 1,000 free searches, which is like quite a lot. I think this is good. Let's have a little look at this. Okay. All right. So we can install another package. We need to grab an API key and set an account. That's not a problem. Okay. Here's actually a really good example. This is good to talk about. So this is what the model will produce. This is the JSON that the model should produce. They've created it manually, but a model, like your LLM, Gemini, or whatever you're using, should produce this, right? With all of the kind of appropriate inputs to the function. And in our case, our only input really was the query, but here we've got a bunch of other different pieces. Actually, there were also these things as well, the tool ID and name and type, which we handled in our, how do we handle this? Yeah. These are used by LangChain, and these are part of the things. This is part of what's done when we wrap with an add tool decorator. Okay, so perfect. So let's see. Okay, so the tool that we're passing in here no longer works. So let's make a new tool, and we're going to use it. Do it using LangChain's own functionality. Hooray! So let's pip install this. Sick. Tabby. Okay. And while that's running, I'm going to go grab an API key. You should do this as well. So let's make an account. I'm actually going to stop sharing my screen while I do this. I'm going to dox myself. Oh, sorry, I had something pinned to the screen this whole time. I didn't realize it was a comment. What is this comment? Stack Overflow, not returning results. Okay, so there's a similar issue. We tried the Google API. Unfortunately, the Google API costs, and I don't really want to spend any money right now. I want to make sure this is free and accessible for everyone, so we can avoid that. Yep, Sapapi or Tabali, there are like a bunch of other different ones. We're using Tabali right now, so I'm going to make an account. I would recommend you go ahead and do the same. Alright, I'm going to stop sharing my screen, and you can do this yourselves, but I'll talk through what I'm doing as I'm doing it in case you're struggling with the API key process. I'm going to put in my email address and verify that I'm actually a human. I need to sign up. I don't need to sign up. Let's generate password. I use a password manager for my password generation. Would recommend. I use Bitwarden. Verify my email. Hello. For anyone who hasn't met, totally not Fritos, this is Ryan Lay. Welcome to the stream. Love you too, Ryan. Oh my gosh, so wholesome. If anyone hasn't checked out the schedule recently, the stream immediately after this one is with Ryan Lay, looking at, I want to say it's like natural code, or like maybe this is like natural like algorithms and this kind of thing. Not done a ton of it myself. I did one module on this at university in AI search, looking at like some of the various natural algorithms that exist for search, which was super cool. So maybe that's the kind of thing. Yep. Okay. There we go. Pretty much nature of code, simulating natural systems. Awesome. That sounds so cool. I'm definitely have to drop in. This is gonna be great. This is gonna be great. Okay. I'm making an API key for anyone who's not clued in, and I've copied it now, and I'm going to close all of those tabs. I'm going to go back and put it in my .env, and I need to call it something specific, I think. Okay, I'm calling it Tavily API key, and I've saved it, and I'm closing my env. Right now, I'm going to be back up on screen. Perfect. Okay, so I've thrown in my API key, and you can do the same thing. I just put it in my .env here, and I called it Tavily API key here. This exact syntax. I thought, you know what, let's follow a similar syntax and naming convention as the little documentation there. Okay, and like we're loading in everything from env already, so this is good. So what's the next thing that we need to do? Let's continue using this tool. Okay, so we need to import using LangChain. So as you can see, like as we continue to use LangChain more and more and switch away from doing things and implementing things ourselves, it's getting much easier. We can just import things directly. Blah 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 blah. This is all kind of stuff which we've done. We've produced much of this ourselves. All right. Oh yeah, we can do this later actually. We don't need LangGraph right now. Okay, so everything else should be fine. Let's go down to our tools section and throw in a new tool. It's going to be Tavily search tool, and this is again just imported directly from the LangChain Tavily library. So you can check it out if you want. I imagine honestly that implementation is not going to be like crazy different to us in some ways, although this is like handling a lot more cases and things, potentially dealing with images. It's got all sorts of bits and pieces here. This is cool. Crazy, look at this. I wouldn't want to structure this that way myself. Okay, and then they're checking if the results are empty. What's this here actually? This is interesting. Okay, it's generating some helpful suggestions. This is really good, right? This is an example of what like a good tool looks like, okay? So it's handling extra different cases, depending on what kind of errors come up where we don't get any results, thinking, okay, why is that? Now, I think in our case, when we were using DuckDuckGo, it was just DuckDuckGo, not working. So I'm not getting too bad about this. And in general, the kind of queries that we're using are fairly simple, but if you wanted to build a more comprehensive agent, the implementations from LangChain, usable out of the box and really kind of great. If you had something really specific you wanted to do, which they didn't have a tool for, so we can like check out all of the tools that LangChain has available. They've got search tools, they've got coding tools, they've got productivity tools. Look, you can link up to your GitHub, you can link up to Gmail. Free with 250 quota units per second is a lot. That's crazy. Web browsing, databases, finance, and then we've got a list of all of the tools. Again down here. So there's quite a lot of tools here, but like not like everything that you could possibly want, right? And so you might end up having to build a tool, and hopefully the code that we've got here is useful. We're going to build another one of our own tools in a second, but first let's go and fix this. Perfect. So we pass in our tools here when we call our agent, right? Remember that when we initialize our agent, we pass in our tools and we bind them to our model. Okay. Great. Perfect. So, where are we at? Well, we have one tool. We've got a search for web tool, but maybe we want a different tool. Yesterday I spoke a lot about like, oh, what about Wikipedia? But like, well, encyclopedias in particular. But like, let's use like Wikipedia as an example. Let's build a Wikipedia tool. Again, I think this does exist in LangChain, and their implementation will be like more comprehensive than ours. But I think this is good practice. Okay. So let's define a tool. Let's call it Wiki Lookup, and let's say that we want to put in topic, and we will take that in as a string, and so we will let's put in a doc string here. Get the first paragraph from Wikipedia for a given topic. Okay, and this is cursed. Thanks for this. Sometimes Copilot is great, and sometimes it does just get in the way. Okay, and let's have a print statement in here, and we will print looking up Wikipedia for this topic. Okay, and is this the correct? Wow, that's crazy. That is the correct URL that we want. Well done, Copilot. And so yes, we will do r equals request.get URL timeouts equals 10. That's fine. And then let's say if our r.status code is not equal to 200, we will return that Wikipedia lookup failed. Otherwise, we'll grab out the data from our request. Let's print the data, why not? Get some extra logging in there, and then we'll return the data with the extract. Yeah, I think this is fine. This is good. Okay, perfect. So we now have two tools, and I think this tool will just work out the box. So let's try our same search again. Okay, so we just add it in here, right? We just got a list, we just add things in. Okay, so let's give it a go. Let's see what we get here. We'll rerun our agents. Close this up. Okay. We'll give that a minute to think. Capital of France is Paris. I'm able to browse instead. This is good. This is good. This is what we expect. Okay. All right. So it's searched with Tabby search for the latest news about Paris. Perfect. We need to make this output more readable. This is like not great. Yeah, so it's found some news. This is great. It's found something from CBS News, tagged Paris, today's update, Goldworth, whatever, Natural History Museum. Oh, yep, it's searched. It's got a couple of different URLs. Actually, this is good because we limited it, remember, when we created this tool to 5 max results. So we've got a few different bits and pieces. Capital of France is Paris. The latest news includes gold theft from a museum, early establishing a Paris headquarters, and updates on strikes and protests. Okay, so it's picked out some bits and pieces. This is fine. This is good. Let's ask something more encyclopedic. Let's ask a question like, who was Alan Turing and where was he born? And I'm hoping that instead of just searching for this, it's going to use our wiki tool, and hopefully the wiki tool will work. That would be like really nice. But you can see here now that actually, like, tools provided through LangChain are like super easy to just get set up with and use. Okay. Okay. So our minimal chain response. Yep. It just spat out the information that it knew. This is fine. Agent loop response through an error. So this is good. It's weird that we didn't catch this error, but this is fine. Number of function response parts is the number of function call parts of the function call return. Call term. Okay. This is. Argument provided to Gemini. Interesting. Where did this originate from? I don't think this is an error in our code, is it? We don't ever call the tool to rewrote, so nothing has changed. Do we? Do we ever call the tool to rewrote? No, we don't. We don't. Okay, so nothing has changed. Let's just rerun that. That's weird. I haven't seen this kind of error before. This is just a huge. This is actually a terrible thing to do. Don't do this. Let's grab the specific. I was gonna paste it into Copilot, which is why I copied the whole thing. I was like, you know what? Let's just Google it. I guess probably pick that up. LangChain, and then we want chats. What is it? This is actually really good. Okay. Let's check out this. So I suspect, let me talk about my thought process now. So I suspect what's going on here is that we're passing in, I'm assuming this is going to error again, oh no, it didn't error, okay. Oh, it tried a lot of searches. Actually, wait, this is just a bugged. This is a bugged app again. I don't know why my base code does this. It's really annoying. So we tried to look up Alan Turing. It seems like a sensible thing to do. I think if we go to Wikipedia and we say Wikipedia, we ask for Alan Turing, yeah, it should have produced this. This is a bit strange to me. It might be because it's got like some formatting problems. Maybe it's an underscore instead of a space. But I think that should be fine. Okay. Wait. Interesting. So we got a 403 status code, which means that we don't have permission. Oh. Again, this is quite strange because I've used this Wikipedia lookup tool before, and it's been fine. Wikipedia. Documentation. Let's have a see. So we definitely not hit more than 200 requests, so I don't know why we're getting 403. Yeah, this seems like it should be fine. I wonder if it's because we don't have wondering it's because we don't have a underscores instead of spaces. Let's make our docstring more descriptive. This might just do it. And this is what when I was saying earlier about like how important the docstrings are. This is how our model knows how to use the tool, right? And in this case, it's putting in the topic as Alan Turing with space, and that's not going to work. It needs the underscore. It is strange to me that it's throwing off 403. This is whatever. Let's rerun it and see what we get. Yeah, good shouts from the chat. An issue with the formatting. I agree. I just wasn't expecting it to be a 403 for that. Okay. So it's still getting a 403. Let's ask our good friend. We'll put it in agent mode, on the note of agents. Our Wikipedia lookup is throwing a 403 error. Oh. Sorry now, stay still. Close enough. Claude will understand. Okay, this makes sense. Sloppy API request from me. So one day, maybe with LangChain, you can build an agent like Copilot. No, you can actually build extensions with Copilot. I've seen some really cool Copilot extensions at hackathons where people have like little characters interacting as you work with Copilot. That was really cool. Actually, I think that was maybe a Rue code extension, but you could do similar things with Copilot for sure. Okay, so what do we change it to? Let's read this. Right. So we're giving it a user agent, and we're handling our errors a little bit better. Perfect. Yeah, this is what I would have expected of 404. For the error with no, where we had spaces instead of underscores. Oh, it's going crazy. It's trying to fix our our DuckDuckGo tool. I don't think that's gonna work. Yeah, I'm gonna extra question mark function. It's just going crazy right now. What is this? Oh, we have an extra quote. Oh, that's not from us. That's from Copilot. Okay, right. We can skip that. Let's just stop you. There. Okay. So, do I want to keep this change to our tool? No, and no. Do I want to keep this change? Yes. Why is it gone down here and changed things? It's trying to fix some of the linting errors that we're getting, but like these are not the end of the world. Yeah, I'm just going to ignore that actually. That's fine. Okay, right. Let's give it a go this time. So, for anyone who didn't quite catch that, we weren't passing in a user agent, and I think this will have fixed it. I don't really want to pass in like an email address here, so and I don't think it's needed. We can put in the GitHub. Like, I don't mind doing that. I don't really want to be in PowerShell either. Yeah, okay, whatever. It's fine. All right. Let's see what we get. Yeah. Thank you, Ryan. I agree. I'm feeling like this is gonna be better. Okay, this is all right. This is better than what we had. Let's have a little read through our fairly horrible debugging statements. According to Paddington, London, England, blah blah blah. This is the original minimal chain. This is just using its own knowledge. And our agent has successfully searched up and grabbed some Wikipedia data. And let's see what it's got out. It's got description, how long he lived for, his date of birth and death, a little description, doesn't return place of birth, okay? And so when our model handles this, it's not getting that information. Doesn't have the functionality to look up the summaries for. And this is because we've limited our Wikipedia lookup to only be a summary, right? So if we head back on over to the API, like, we could not limit it to the summary. We could just limit it to, like, well, we could give it like a bunch of these different options, right? We could do loads of different handling here. I'm not going to. I think hopefully you know how to change this. If you wanted to, you could just change the URL that we're pointing at. We could even, right, provide all of this as information for the function and allow our model to select this, okay? And this is maybe a good way of doing it, right? Allowing our agent to think, okay, what do I actually want to get? I want to get out the place of birth. Where can I find that information using Wikipedia, okay? And it would undoubtedly be able to get out Wikipedia always has the place of birth, right? So this would work, and this is great, okay? So I'm going to leave this as is. I'm happy that this tool is working, and if we wanted to make it better, we could, but for now, this is like functional, and we have 2 tools. Okay, the next thing that I think is most interesting to do with agents is ragging. And so let's make a new section down here with a comment, not just a number. And do we have any questions? No, we're happy. Okay, perfect. All right, so let's build some rag integration. And it's not going to be optional. Thank you, Copilot. We will. Well, it could be optional, but let's get started. Now, this isn't going to be like this workshop. The focus of this workshop isn't on RAG, but RAG is like an important part of building an agent, in my opinion. And so we'll talk a little bit about what this is. Okay. Cool. So maybe like actually before we kind of get into the writing code, we'll like have a little discussion about what we're doing here. Okay. Cool. Perfect. Okay. So as we've discussed, LLMs have limitations, right? And these limitations include the fact that training data might be outdated, or they might not know each topics. This is very true. Okay, and when we ask for precise factual detail, there's an emphasis on that, can often lead to hallucinates. Okay, and this is not great. And also, models don't know our private information. So let's say we're building an agent to work with a healthcare company, okay, and we wanted it to allow, I don't know, doctors to query about like a patient's kind of well-being, and we wanted to provide the patient's health data. We obviously can't have this public. The model can't be trained on it. We could fine-tune on it, or we could pre-train on it. We could train from scratch on this data. But this is a terrible idea because it's very expensive to do, and doing that with all of our patient data, which might update all the time, makes absolutely zero sense. We could also, right? We could put this information into the prompt, but this doesn't scale. If we have like 3 million patients, right? I mean, that's an absurd number of patients, but maybe somewhere like, I don't know, New York or Shanghai or, you know, big cities, huge numbers of patients. I mean, even in small cities, they're going to have like tens of thousands, if not hundreds of thousands of patients in larger cities as well. So, like, we can't just put everyone's healthcare data into the prompt. That is a terrible idea. As well, it doesn't scale. It doesn't scale, okay? So we need some way to give like potentially private or potentially like niche information, right, to our model, okay? And this is where RAG comes in. So RAG, can I have a capital please? RAG is retrieval augmented generation. Okay, and the way that it works is we have some query that arrives to our model, and then the system retrieves a vector index using no, let's be more specific. Retrieves from a vector index. There we go. The top K relevance, and it's not just documents, but it's document chunks, bits of documents. It's unlikely that we'll pull in a whole document, okay? But though this will depend on the length of documents and what we're asking, okay? Retrieved text is context injected into the prompt to the model. Okay, so instead of giving the LLM all of the information right into the prompt, we give it just the most important bits and pieces. Okay. Yeah. Okay. Fine. That's bad. And then the model generates an answer, and then this is grounded in the retrieved text. Okay, you might have heard of model grounding before. We can ground with Google search, for example. This is maybe something you've heard of if you've been to some of the Gemini demos. Sometimes the ML team will talk about this. Okay, so this has some benefits. Less likely to hallucinate, and it can answer questions about private data. Okay, great. Excellent. Okay. So let's write some functions that will do this. The first thing that maybe we want to do is we want to load our documents. Okay, so let's create a function called load documents, and we're going to have a folder where we're storing our documents. Let's just be a string, and then the output is going to be a bit funky, so let's leave that for a minute. In a minute we will put in type in for the output, but we'll get to that because this might be this might be some talking through to work out what we're doing. So for P in our path, which we're just grabbing from the folder string, we're going to iterate the directories. Okay, and if p dot suffix dot lower is in, and we're going to pass it in explicitly .txt's or markdown files, because these are easier to work with, but you can do all sorts of things. Okay, and then we will read the text from these. And encoding. Okay. If we have any errors, we're gonna ignore them. Okay, perfect. So you can see here we're opening the file and we're just reading in the text. Okay, and then what we're going to do is we're going to just add this onto our docs. So this at the moment, docs is a list, and we want to add in to our list, or append to our list more accurately, a dictionary. And this dictionary is going to be, maybe we'll have a document ID, which we will put in as just a string of what the document's called, and then just the name. Let's close the bracket there. And then, yes, the next thing that we're going to want in our dictionary for each document is going to be the text. And then maybe we could have some metadata. This would be another dictionary. Yeah, I mean, like we could put in like source, for example, and then have this. I mean, in this case, the document ID and the source is the same thing, but like, just for example, this is maybe like a useful structure to have. Okay, and then like we could also handle like other bits and pieces. Now you might remember if you were at the stream yesterday, I talked a little bit about PDF Plumber and like how it was annoying because it wasn't installing properly. So we could like, for example, handle PDFs, but I don't think we're going to. Yeah, I mean, like, if we wanted to, we could just do exactly the same thing, right? We could just check if the suffix is equal to .pdf. We could also do the same thing for, yeah, we're gonna do that. But we could also do p.suffix. We could like check for all sorts of file types and handle them. Yeah, we could do CSVs. We could do JSON. Looks like Copilot thinks we should handle JSON. I kind of don't want to. Okay, but like if you wanted to, you could adapt this function, right? And let's just return the docs. Okay, that's pretty simple. We're loading another. Okay. Right. Now, what we need to do when we are dealing with text is we need to get some kind of embedding. And when we embed things, we're just representing the text in what's called an embedding space. And we do this with a model that just translates it for us, basically. And so what we're doing is we're taking all of our words and we're turning them into vectors. This is what it means to embed things. And a vector is just like an array of numbers, which have some kind of distance, i.e. magnitude, think of it in physical space, distance, and also direction, right? So, for example, if we said 3 kilometers northwest, that would be a vector, right? Because we have a direction, northwest, and we have a distance. And in this case, that would be, like, you can think of it as like a line going out northwest, so this way, I guess. I can't remember whether my camera is mirrored or not, but you can imagine, right? And so we could work out how far we're going in the x direction and how far we're going in the y direction. And in this case, we've got 2 dimensions, x and y, and so a vector might be, like, I picked a really bad example with 3 because that's not easy to work out with Pythagoras theorem in my head. But like, we could go like 1 kilometer west and 1 kilometer north, right? Or 1 kilometer in the negative x direction, 1 kilometer in the positive y direction. This is a vector, right? And we're basically just representing all text as vectors. And the reason that we want to do this is because if we walk, for example, 3 kilometers northwest, and then we also walk 3 kilometers northwest-west, or north-northwest, then these 2 vectors are quite similar, right? And when we embed text, we want text which is similar to have similar embeddings, i.e. it's in a similar space in the embedding space, right? I.e. the endpoint is kind of similar. The vectors are similar, right? And so we want to basically embed our text, and this is going to be a bit funky to do. You can do this in lots of different ways. If you've been to any of the MongoDB workshops, often these are used as vector databases, and I'm sure you can check those out. We had some this week at the start with Rosendo, but we're going to use this. It's called Vice. I think I'm pronouncing that right. I actually don't know how it's pronounced. And instead of handling our vector database remotely using MongoDB, we're going to just handle it locally because it's easier. But if you were to build this into a full app which you wanted to deploy, you should probably use something like MongoDB, or there are a bunch of other different tools. Okay, perfect. Okay, so let's first create a helper function called chunk text, and this is going to split our text up because we don't, like I said, we don't want to return a whole document unless the document is just like 1 chunk size. So we want to have like some kind of pre-decided size for how we're going to split up our text. And actually, I've just remembered, I'm going to go and hop up in a second and fix something in our document loader function. And let's set the chunk size by default to 500. We're passing in the text here. This is the text that we just grabbed out from here, so this is nice and easy. And then maybe we want some overlap as well. And we'll make the overlap slightly bigger. And then we are gonna have a list of strings. And you can imagine why we're gonna have a list of strings. We're just gonna have a list of the chunks, okay? And up here, we didn't put in our type hints. Let's do that now. We're gonna have a list. Copilot's spoiled it for us. We're gonna have a list because this is what docs is. And then within the list, we've got dictionaries, right? We're appending dictionaries. And these dictionaries can be strings, or they can be anything, really. They could be more dictionaries, which is the case. So this is fun. Okay. Why are you unhappy? I think this is pylons just being upset with me. This is pylons just being upset with me. I think this is actually completely fine. Yeah, I know what's up with my pylons today, because this is let's return value on all code paths. None is not assignable to this string. Yeah, I don't care. I don't care. Oh, actually, that's not correct though. That fixes it. Yeah, this is throwing an error because it thinks we've got none as our return, which we do currently. And this was throwing an error because this was in here. Nope, this was in here, and or maybe it was here. I can't remember. Like either way, it is entirely possible that we had nothing. Actually, we could still have nothing, right? If we loop through all of this, docs could still just be empty. But it can just be an empty list, as long as it is a list. So this is, I think this is okay. I think actually that was, oh, it's having a bit of a tantrum for no reason. There you go. Okay, so tokens are equal to text.split. So we're going to split up our text into tokens, right? And then tokens are just like little bits of text, not necessarily words, but sometimes parts of words. These are just common substrings which we see together. And this is what we use in LLMs. If you were my little intro for this stream series yesterday, we spoke a little bit about what LLMs are and what they work, all of these things. Okay. So while I is less than the length of tokens, which is all of the tokens that we have, we're gonna say chunk is equal to tokens. Perfect. And so we're just grabbing out a chunk of size 500 between the token that we're starting at and the next size. And then we're gonna append, yeah. We're basically just gonna throw in a chunk to our chunks list. Lovely. And then we're going to increment, and here we have to be careful because we don't want, we want to make sure that we have this overlap, right? So the way that we're going to do that is we're either going to increment by 1, or by the difference in the chunk size and the overlap. So in this case, this is 400. And this means that each time, if we shift 400 at a time, and we have a window of size 500, we have an overlap of 100 at each time. Okay, great. Okay, and then we can just return chunks. This is good. How much time do we have? We've got some time. Okay, so let's see. Now, we've got our document loader, and we've got our text chunker. We need something that builds or loads the index, and we don't really want to be doing this over and over again. This would be very inefficient. So instead of just building a vector store naively, we want to check if we've already built one, and that also means that when we build it, we want to save the vector store load field. Okay, so the next function that we're going to have is going to be define build or load index. Okay, and then we're also going to have, just thinking about this, once we've got our index loaded or built, we're also going to have another function which is just retrieving relevant docs. Okay, cool. So these are the two next functions that we need. This is good. I'm going to just check the questions. Let's see if we've got any. How are we doing? Looks like no questions so far. I hope you're all having a good time and happy with what's going on. Can you not do that actually? Thanks. Perfect. So I'm hoping that ragging is making sense to you. You're all pros at retrieval augmented generation, and we can just build this. So let's do that, and let's. I'm going to go like a little quicker here, just in the interest of focusing on the agentic stuff and not so much on the implementation of rag. But I also want to talk a little bit about LangGraph and MaxMed yet. So I'm going to try and wrap this up in the next. Actually, we need some more. We need some more bits and pieces in here. Let's define some constants, and let's actually do this. Maybe we'll do this at the start here. Define rag. And so we need an embedding model, this is actually going to be the name technically, and we're going to use this sentence transformer library which we loaded, and yesterday was upsetting Pylons all too much. This one is nice and small and easy to use on your local device, which, as you can see, like I'm just in VS Code, I'm just running things on my CPU. We don't need anything complicated. Index path for our vector database, so we'll call this chunks dot index, and then we need a chunks path. Perfect. Okay. Right, great. So let's hop on down here. And if anyone's following along, fixed, I'm going to just commit this, fixed tooling and began rag implementation. We'll just commit this and just make some changes. Oh yeah, perfect. Yeah, we have to merge in because I create a README on GitHub. That's fine. Perfect. Okay. Right. If path indexed path exists and path, so we're just basically checking if we've already got all this stuff. Okay, and yeah, this is all correct. We're going to load in the index. Nope. And then we're going to open up our chunks path and load in our chunks using pickle. Nice and easy. Okay, great. So if it doesn't exist though, let's also actually define the embedder. Okay, and this is going to be sentence transformer embedder model name. And then we're going to return the embedder too. Okay, and then if this is not the case, we're going to load our documents. Okay, and this is going to be from the docs folder. And don't know why it's unhappy with that. Oh, that would be why. Let's do that. Great. Okay, and then all chunks is going to be just an empty list for doc and docs. Let's create the chunks, and so we can do this using our chunk text function, and this is just going to be the text from our doc. So we're looping through the output from load documents, right? And then we're chunking it, right? This is exactly what we said we were going to do. Okay, perfect. And then for I chunked in enumerate over the chunks. So we're looping over all of the chunks that we have, and we're going to add them into our total chunks list. This is just all of the chunks across all of our documents. Okay? Right, and this is going to be a list of dictionaries. We want the chunk ID, which is going to be, let's put an F string, yeah, we'll call it doc ID. Oh, it's done a lot of filling for me there. Yeah, perfect. So we're basically just making sure that our chunks are named by the document ID, and then also chunk, and then the number that chunk is within the list. Okay, and then we're getting out the text, that's fine, and then the metadata, that's perfect as well. Okay, great. And we're getting there. We need to now embed it, so let's create the embedder, and we will get the embeddings by doing simply embedder.encode. And so this is taking what we have, strings, and putting it into this embedding space. And it's going to be C, text for C in all chunks. Yep, that's fine. So for every chunk in all of our chunks, we're going to embed each chunk, right? Each bit of text in that chunk specifically. Remembering that our chunks are stored as dictionaries and not just the text. Okay, and we do want to convert it to NumPy. I'm just going to put this. Yeah, this is fine. This is fine. And then, let's put in a progress bar as well. Okay, right, great. And then we'll grab out the dimensions of our embeddings, and we're going to use that to store it in our vector database. Great. And then we're adding that onto our index. And now we need to make sure that we write all of this stuff so that we can load it again in the future. So save index on chunks, and we can do that with files.write index. Perfect. And then with open chunks path, and we'll just do a quick little dump. This all looks good to me, and then we'll return everything. Okay, I don't know why you're having a tantrum. I think this one parameter X. Let's look at the documentation. Yeah, this is what we're doing here. This is okay. Again, like this is not very descriptive. If you're interested in this library, it's maybe a useful one to get familiar with. It's very quick and easy in general. It's not a complicated thing to do. No, this is not really what we want. No, look, this is exactly what we're doing. It's just pylons. It's just pylons. Ignore it. Ignore it. Okay, right. So we have built or loaded the index, and let's actually, yeah, we don't need to. I was going to say we can do that now, but we don't actually do that. So let's retrieve the relevant documentation, and this is also going to be a tool. So maybe actually we'll rejig the order in here, because it would be nice to have this with the other tools. So I'm going to take this and I'm going to cheat by popping this up here. And I'm going to call this section 3. And then I'm going to call our tools section 4. And I'm going to call our agent loop section 5. Great. And now we can take this here. Now this is just another tool. Like any of the other tools that we've built, except instead of interacting with an API, this is going to be interacting locally. Okay. Okay. So we're going to retrieve the relevant documentation, and let's have a little think about this. So, what do we want to take in? We want to take in the query. Okay, and this is going to be string, and then we probably want k, which is the number of chunks that we want to return. Okay. We want this to be a, what output do we want? I don't think we want a string. I think we want a list, because we're going to have a list of the different bits and pieces, and we probably want it to be a dictionary because we might want some of their associated metadata, for example, which document it came from. So it's going to be a list of dictionaries, and it's going to be string any again. Okay. Right. Perfect. Okay. Why are you down here? Okay. I see. I see. Right, and we need a doc string here because otherwise it's going to have a tantrum. Okay, all of this, let's just delete. I just wanted the doc string. Let's see if the doc string's okay. Retrieve the top k most relevant documents for a query using the base vector index. And we take in the query, which is the search query. We take in k, which is the number of top relevant documents to retrieve, and then we return a list of the top k relevant document chunks with their metadata. Perfect, that's exactly what we want to do. Okay, so first of all, let's put in some print statements. Can we stop predicting like everything? Okay, and then we're gonna, yeah, this is good for logging. Okay, and then we're going to grab the embedder again. Okay, and this is why we made this a I'm wondering if it makes sense to initialize the embedder just once, because otherwise we're doing it when we're loading or building our vector store. Yeah, I think let's embed embedder, and then we're gonna do encode. So like before I finish that, we need to go and define this, and let's do it up here, and let's throw it in here. Great. Okay, and now every time that we, what is it, here, instead of doing this, we can just get rid of this, and we don't even need to return this, and we can get rid of here. We don't even need it either. We can just use embedder. This is still having a tantrum. Right. Okay. Now it's a global constant. This is fine. If we wanted to change the embedder in different places, we could, and we wouldn't want it as a global constant, probably. But this is alright for now. Okay, and then we want to embed our query, because we want to, remember what I said, we want to have a vector and a vector, and we want to see how close they are together. And so we want the vector of our query, and we want to say, okay, what is the closest bits and pieces in our data to this vector? Okay, and to number. And now one thing to note maybe is that if you were going to change the document loader to include CSVs, you probably wouldn't. I mean, like, depends what your CSV is. If it's just a CSV of numerical data, this is going to be fairly meaningless, right? Embedding numerical data in a vector space and then trying to match on it using this method, at least, is not really going to work. At least I don't think it will. Yeah, but there will be ways around that. Like, if you wanted to search for, if you wanted to search for specific numbers, this would maybe work. It's just that, the way that we tokenize things, it might just match on everything, because strings are more unique combinations that can have many characters, whereas series of numbers tend to break things. This is why LLMs are not supposed to maths, right? Because it's much harder to learn than patterns. Okay, right. So where are we? We are up here. Okay, and we want to convert to NumPy. Yes, we do want to do that. NumPy makes our lives easier. I believe you've heard of NumPy before, and so we're going to grab out using the search with our query, and also getting the top K number of things. Something's going on here. Have I not imported something? This is possible. This is possible. I don't think we need to import. Productive ASMR. Sorry, I'm just tapping back in to check the chat in case anyone's got questions. Speed, I mean, that's the goal. I don't know if we're really achieving that. I kind of want this fixed in the next 2 minutes. I think this is doable. This is doable. Welcome to those who are joining. I'm afraid you're joining near the end of a 2-part stream series, but you can check out the earlier parts on YouTube. Yeah, I agree that this is not defined. I'm just trying to work out where we want to pull this in from. Let's have a little look. We probably just need to pass it in as an argument, I want to say. Yeah. Let's do this. Okay. We will say index, and what is index? Yeah, it's this. What are you happy about this? Non-default argument follows. Oh yeah, lol. I need to just get good. Apparently, this is basically what Copilot's saying. Fine. Yeah, I'm happy with this. Let's just do this. Okay. And this is still unhappy because we haven't finished writing our function. This is fine. This is unhappy because arguments missing parameters k, distances, labels. It's just not there, is it? This is fine. This is fine. Stop having a tantrum. This is Pylance just being sulky. This is going to work. I'm feeling confident. Okay, for score index in. I'm going to zip these together. This is actually, none of this is what we want to do. Okay, I'm going to grab out the chunks. Let's pass in the chunks as well. Yep, that's correct. Okay, so pass in the chunks. We want to index these. So basically, we're grabbing out, saying, okay, what are the highest matches using the search, and how can we pull out the text back again? Well, we have a store of all of our chunks, helpfully, and we can just index on that, right? Okay, and then we can append all of our results. And let's see, we've got a chunk ID. We've got the actual text. That's good. That's the most important thing. We've got the metadata, we've got the score, which is a float, lovely, and then we can just return results. So let's print these as well. This is helpful, and we'll delete this so that all of our tool calls are just wrapped in this. We can delete all of these later, but now this is good. Okay. Right. I think this is looking good. We built an agent, and I think it will use our documents. Unfortunately, we don't have any documents, and we also haven't initialized any of this. So let's do some things. Yeah, okay. Index all chunks, and yeah, we can have a data folder, and then so we're going to build or load our index. That is great. And then we basically don't need to do anything else here, I think. Although, when we add in our tool here, I'm just rethinking how we've done our... When the model calls the tool, it needs to know... Yeah, it needs to know... it's not going to be able to input index all the chunks itself. It's not going to know where to find them. I'm inclined to say we actually change this. Yeah. What we're going to do is we're going to pop this up here. Actually, we can do this. We can do this fairly well. I think this should happen here. Yeah, let's do it. Let's do it here. Okay, so at this point we're gonna pull in, and maybe we'll make it clear that these are. And these are not clusters. Let's change it. Let's not make them clusters. Why have you done this? Okay, what do we need? We need index. Index. And then in the tool, all chunks. Okay. So we're using like global variables here. Probably the best way to do this would be to handle it within our agent loop. Okay, so it would perhaps be sensible that when we initialize the agent loop, then we run this, and then we can maybe provide those variables to our model directly, or we could set them as default. Actually, yeah, probably the sensible thing would be to set them as default variables within, like, as default parameters. Sorry. That's probably the best thing to do. But for now, this is like a slightly hacky solution, but it works. This will work. Okay, so we don't need anything here. And I think this is just gonna work. Yeah. Cool. Okay, let's give it a go. Let's give it a go. And first we need some documents. And I believe I have some pre-prepared. I did some tests earlier, and I'm gonna just pinch these directly. Can I copy directly in here? I think I can. Yeah, nice. Okay, perfect. And so these are like, principles of agentic behavior. Little notes on the architecture, right? I mean, ideally we build a Gradio interface. We probably not mapped on this. This is okay. We discuss a few little bits and pieces here. We didn't actually get onto this either, but we did the first 3 steps, so this is good. Okay, and these are basically just descriptions about this project. So we could ask down here in our agent, we could say, tell me about, and let's pick something. Tell me about. Yeah, tell me about principles of agentic behavior. Now, I don't know if it will Google this, or whether it will use the data available. What I'm going to suggest we go and do is, you have a agent, you should call tools. What did we call the tool name? Okay, relevant docs. If relevant docs are available, use the tool, prioritize these using the tool over search or over other tools, e.g. search. So we're basically just telling it, okay, prioritize using local data first. Okay. And let's give this a go, and hopefully we're going to get something working out here. And we're feeling too confident. Yeah, we haven't tested any of these functions midway through, but I'm feeling good. Okay, so we've got our chunks indexed in our vector database and also stored directly. Okay, so the minimal chain response has given this really long spiel from its own training data. This is fine. This is acceptable. Okay, and let's see what we get from the agent loop response, and then maybe we'll try and wrap up 5 minutes before the hour. I know that yesterday's workshop was long, so okay, right. Wow, look at all of this. Okay, so agent loop response, message history, you're a helpful agent, blah 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 blah. So it has searched by the looks of things here. For principles of objective behavior. Okay, so tool calls. I really need to this is, if you want to continue this project and build it into a more comprehensive agent, I think hopefully you've got the tools to do this now. One of the things I would recommend is doing vessel logging, and we'll talk about that in a second. Okay. Just doing all sorts of searching. I think we need to be clearer in our system prompts. And only if the results are full matches should you call another tool, e.g. I'm also gonna check yeah. Okay, this might work better. Sometimes it can just be a point of not the output. There we go. This is what I want. Okay. Right. If there's an example, could I run an example? If there's time, sorry, could you run an example of query data from another source? Do you mean from not a local source? My suggestion would be that this is I probably don't have time to build something quickly and show you. I would definitely check out the MongoDB stream that Rosendo does. We had one earlier this week in Global Hack Week. Rosendo talks through vector databases specifically in one of the streams, so I can link you to that if you're really interested. Okay, right. Okay, we just Google stuff again, I think. It just loves using. It just loves using. What I'm going to do, I'm going to cheat. I'm going to just remove that tool. And then we'll see again. Okay, cool. I'm glad. Let me know. Yeah, do let me know if you need any help trying to find that stream. I can give the tool. Perfect. Okay, this is looking much better. Okay, so it's used our tool called retrieve relevant docs, and it's called this up with the query principles of agentic behavior, and it's queried for top three results. And let's see what the results are that we got out. I should have printed them somewhere actually. Top three relevant documents for this query. So we can see that we've got a list of dictionaries, and the first one is principles of agentic behavior. An intelligent agent follows a reason, act, observe, reflect, and then explains all these different pieces. And that's got a score of 0.87. By the looks of things, yeah. The next one is talking about the system architecture that we have. This has a score of 1.16, and then this one's a score of 1.2. And we can see that the model has used this almost verbatim actually. The principles of agentic behavior involve a loop, reason, act, observe, reflect. Good agents keep reasoning transparent, use tools only when beneficial, handle errors gracefully, and record a trace of actions. Agents interprets the user's goal and context, chooses the best action, reads the output, and decides whether to continue what's done. So hopefully this is a really great place to end the workshop with some practical code that's fully working. So I'm going to commit all of this, added data, and completed RAG implementation, and added sample data. Okay, perfect. And I'll see this changes up. Nice. Alright, so you can go and check this out on my GitHub. I think the link is already in the chat. I put it up a little bit earlier. Very quickly, I wanted to talk about two things. I wanted to talk about LangSmith. LangSmith is great. Let's see. I haven't actually used LangChain Academy, but this seems like pretty great. I know lots of you were talking about this recently. I really want to look at the docs though. So LangSmith allows you to get out the traces, and you can use this for free. It's really great. Traces are just basically all of the different steps that are happening, and it integrates really nicely with LangGraph. And you're going to maybe you're maybe going to hate me, kick yourself for this, but actually LangGraph implements a lot of what we've already done. It allows us to build agents much more quickly. In particular, somewhere we had if we go to any of these, any of these tutorials, probably down here. So using within an agent, instead of building the React loop, you can just call it. And this you can import using LangGraph. This is pre-built for us. We've built it ourselves from scratch, and hopefully through this your intuition has been leveled up for how an AI agent works. And we've still used a lot of the tooling that LangChain has provided, in particular calling tools and how we are creating our clients. So I hope this has been super satisfactory, but if you wanted to develop this further, you might prefer to swap to LangGraph. This allows you to model agents and their interactions with edges and nodes, and LangSmith allows you to trace this really well. I also do like, I don't know where it is in the documentation, LangChain intro guide. If you head along to these tutorials, I think they're really great. I think in particular the agents one is quite good. We've done similar things to this, but we've built it all, well, not all of it, but some of it from scratch. We haven't used LangSmith, for example, but if you wanted to help getting set up with LangSmith, I think this is a really great way. We've built our own tools from scratch. If you want to do more of that, there's a guide here in more detail, and you can see how to build more structured tools. Verifying kind of input and kind of providing schemas and things can be done through a tool called Pydantic. So that's a library. I really do recommend that. And then if you wanted to use a different language model, it's very easy to get the code to change it. We use Google Gemini because we get pretty good rate limits on that. But the options are there for you. And we can, as I said, create the agent fairly simply here, and we're using the exact same invoke methodology that we've been using as well. But you can get some nice and pretty outputs as well. I do recommend this. Our outputs are pretty cursed at the moment. You can also get messages live as they come out by streaming them. Hopefully this is all making a lot of sense. We also implemented memory ourselves. We used basically just a messages list, which we just added all of the messages to consecutively, but you can use proper memory management through LangChain as well. So I do recommend that. This is like a really great extension to the very simple project that we've built. Hopefully you've loved having an introduction to LangChain and agentic AI as a whole. With that, I'm going to wrap up. I love having feedback from you all. It really is useful for me to know, do you want me to go faster? Do you want me to go slower? Do you want more code, more concepts? So please do give me your feedback. And you can do so at mlh.link/GHW feedback, which I just popped in the chat. And with that, I'll wrap up. Thank you all for coming. And of course, head along to the wonderful stream starting with Ryan Lay in just 2 minutes. That'll be here on Twitch or YouTube, wherever you're watching from, and you can check that out. Let me pop the check-in link for you if you're interested. But yeah, Ryan will be hopping on in just 1 minute, so I will get out of the way. But thank you all for coming. Head along to that. I'm going to be there. It's going to be great fun. And yeah, say hello to Ryan and learn about nature and well, the nature of code, even all of the natural algorithms and systems that we can take inspiration from. So happy hacking, everyone, and I hope you enjoy the rest of the Hack Week. Thank you all for coming. Bye-bye.